Welcome to CSIR Chemistry Insight. In extension of the last video about rubredoxin, I'll discuss about EPR spectrum and the symmetry point group of rubredoxin active site. So when it comes to EPR spectrum, we also name it as EPR, or we also abbreviate it as ESR or EMR, electron paramagnetic resonance or electron spin resonance or electron magnetic resonance. Well, it is a spectroscopy which is related to the active magnetic moment of a free radical or any paramagnetic species. But one point to be remembered is that every paramagnetic species need not be EPR active due to various reasons such as antiferromagnetic coupling due to super exchange and so on. Well, in the case of rubredoxins, whether it is in the oxidized state or in the reduced state, we can see that there are some unpaired electrons, and therefore rubredoxin behave as a paramagnetic species, whatever be the redox state. So suppose if at all we look at the oxidized state, in oxidized state rubredoxin has 4 coordinated high spin iron 3 form. This is oxidized rubredoxin, whereas in the reduced state it has 4 coordinated high spin iron 2 form. This we refer as a reduced rubredoxin. So in the case of oxidized rubredoxin, there are 5 unpaired electrons, whereas in the reduced state there are 4 unpaired electrons. So in either state it looks like both species are EPR active. When it comes to the oxidized form with iron 3, this is found to be EPR active, and 2 peaks can be seen in the spectrum, one at a G value of 4.31 and the another peak at a G value of about 9.42. When it comes to the reduced form with iron 2, 4 unpaired electrons, surprisingly it is found to be EPR silent, though being paramagnetic species. So this could be due to various magnetic interactions that occur at the active site of this even numbered electron species. You can see that in the reduced state it is having 4 unpaired electrons, which is a even number species, right? So just remember that even number of electrons is the key for most EPR silent species, right? So it is concluded that oxidized rubredoxin is EPR active with 2 peaks, whereas the reduced rubredoxin is EPR silent, whereas this one is EPR active, right? This is what we have to conclude about the EPR, ESR or the EMR spectrum. Well, the second part is coming to the symmetry point group. Here we have seen that iron is surrounded by 4 coordinated cysteinyl sulfurs and the geometry looks like a tetrahedral one. So whether it is a oxidized state or a reduced state, it looks like a tetrahedra, but it is not having a perfectly tetrahedral geometry. It suffers from distortions. Distortions could be ligand induced distortions, or it could be a John Teller distortion. So from a perfectly tetrahedral geometry, when I say a tetrahedral geometry, this belongs to a TD point group with 24 symmetry elements, but due to the distortions there is a descent in the symmetry, and due to this descent the number of symmetry elements will drop, and at the active site it is said to be tetragonally compressed one along a S4 axis. So to just understand this, let me draw the same tetrahedral representation in a different way. If at all we hold any tetrahedral model in a different way, this is how the geometry can be seen. 2 bonds are facing towards us, whereas the other 2 bonds are facing away from us, right? The same one, if at all we are looking at a side view of this, so I'm just tilting it, a side view I'm drawing. Suppose it is like these two are facing towards us, These are like away from us. The same one if at all we are looking in this way. Then what exactly happens is if it is a perfectly tetrahedral one. Since there are distortions, it is tetragonally compressed along an S4 axis. So this bond and this bond they come close, and these two bonds they also get closer. So as they get closer, it may look like this. So this is how it is looking like. This is a perfectly tetrahedral one. The other way of looking the same tetrahedral geometry is this, but once there is a distortion, now the geometry will look like this. So if it is a perfectly tetrahedral one, it belongs to a TD point group depending on the active site, and it has a 24 symmetry elements. But as there are distortions, now this belongs to D2D point group. Okay, now let us just look at this. Suppose if this is the tetrahedral geometry, this tetrahedral geometry, it could be viewed in this way also. This is what I am showing now. This is a tetrahedral geometry. Two bonds are facing towards us and two bonds are away from us. So this is that representation. Now coming to the side view, this is how we can look at the side view. So in this side view, these two bonds are these two, and these two bonds are these two. So whenever there is a distortion, I said it is a compressed tetragonally one, so these two come close and also these two get close. So just let us make them closer. Also let us make these two closer. Now once I have made these two closer and also these two closer, it no more looks like a tetrahedron. If you can very clearly see this, it is just looking like a allene. Why did I say allene? In allene there are 3 carbon centers, but there are 2 CH2 units that are staggered to one another. In this case there is only one center, it is a metal, but there are 2 sulfur units which are staggered to one another. So you can just try to correlate allene molecule with ferredoxin, which is a rubredoxin 1 iron ferredoxin active site, and both belong to D2D point group. In this D2D point group, just for a little convenience, here is one C2 which is a principal axis. From here will be a second C2. From here will be a third C2. Here will be an S4, one sigma plane and a second sigma plane. So to just conclude, for the rubredoxin, oxidized form is EPR active with 2 peaks. Reduced form is EPR silent, though it is a paramagnetic species. And symmetry point group of the distorted tetrahedral geometry is D2D. Thank you.